Hello everyone, I'm Nilesh Kumar Singh, working as an assistant professor in ABES Engineering College, Ghaziabad. Our today's topic is demand phasing. So demand phasing is what a mechanism. It is very much similar with the phasing system, with swapping where processes are stored in the secondary memory and pages are loaded only on demand basis, not in advance. So when a context switch occurs, operating system never copy any of the old programs pages from the disk or any of the new programs pages into the main memory. Instead, it will start executing the new program after loading the first page and fetches the program's pages which are referenced. Means you can consider an example of MS Word that suppose one need to require what a blank page, so it will be loaded into the main memory. Sooner the user typed some text, and when it requires to bold a particular code area or text area, so the code for that bold uh, bolding to perform the bold operation on the area, it will be loaded since it is required. It will not be loaded earlier. Means all the pages like bolding the text, italic the text, underlining, numbering, and there are various features. So with all those features are not stored initially. It will be stored one by one and as and when required. So this is what the demand phasing is. So during the program execution, the program reference a page that may not be available in the main memory because it was swapped. Then the processor considers it is an invalid memory reference. That's because the page fault and transfers send a control back from the program to the operating system, which demands to store page back into the memory. Uh, you can see that those are the pages which are stored at various locations. This is the page for bold. Now this is for italic, and this is for word art. This is for something else. So it is as per the requirements. So when the required, let's suppose the program requires what these 17, 18, and 19, so it will be swapped in, and the earlier pages, which were 4, 5, 6, and 7, will be swapped out as it is not required now. So transferring of paged memory to contiguous disk space is what the demand phasing. It includes some valid and invalid bits. With each page table entry, a valid and invalid bit is associated. Valid means what? It is available inside the main memory or memory resident, and invalid means what? It is not available inside the main memory. So invalid bit is set to I on all entries, as you can see in the particular page table diagram. So here we list the number of frames, and here the availability or non-availability of a particular pages. So if the frames available, so it will be denoted as valid bit, and if the frame is not available, it will be considered treated as invalid bit. So during the memory management unit address translation, the valid and invalid bit in page level entities are what the page fault. So valid and invalid bit, as you can see that the logical memory address is having what these frames, and those frames are represented over here 4, 6, and 9. So inside the page table, and along with those frames, there are some bits written over here that is representing valid and invalid. So at fourth frame, there exists A, so that's why it is what the valid one. Sixth is On the sixth frame, it is again a valid. So here it is what the C is representing over here as it is mapping with 2. And at mapping with 5, there is F at ninth place. So all those are what the available. So those are stored in the physical memory. So page table, when some pages are not in main memory, so those page table, those will be stored in the page table. Page fault. Page miss or page fault refers a particular situations where a reference page is not found in the main memory. As suppose considering that we are looking for the D, since it is not stored inside the page table, 3 is not mapped with. It is referencing what invalid with. Means inside the main memory or physical memory, the D is not available. So that is considered as what the page miss or page fault. If there is a reference for a particular page, it will first reference to that very page and will trap to the OS. What happens when the page fault occurs? So operating system looks into the matter and will decide if invalid reference is there, so that operation will be aborted. What happens when page fault is there? So second step would be what? Finding free frames, available frames, and once the free frame available, so it will swap page into the frame via scheduled disk operations and reset tables that indicate page now in the memory and set bit accordingly as validation bits, that is V, and restart the instructions that cause the page fault. So steps handling in page fault is what? Initially loading from the main memory. So that is what the reference one is. Once it is found that a trap is there, so it will call the operating system, and after calling the operating system, it will search for the particular page back to the storage. So once it is found, so it will bring that missing page inside the physical memory and allocate a free frame for that and reset the page table so that it would be located, and it will restart the instructions and rewrite the validation bit. What happens if there is no free frames available? So it is what used by the processor's pages, and it is as per demand from the kernel or input output buffers and how much memory it requires to allocate. So there are various page replacement algorithms. So it will find some pages inside the main memory, but not really in use, which are not really in use, and phase out them. So to do so, we are using different algorithms for page replacements. So it will terminate a particular page, swap out those page, and replace the page with the newer one. So as per the techniques or algorithms available of page replacements, we'll uh, manage the demand phasing. So here are some advantages and disadvantages too for demand phasing. Advantages are efficient use of physical memory, support for a larger programs, faster program start, reduce memory uses, and it will increase what the page fault overload, degraded performance, fragmentations will be a major issue, and complexity will also be enhanced. These are the references which are used to prepare this stuff. Thank you.